Hey, Jeffrey. You had asked about using the derivative of inverse formula to find the derivative of inverse trig functions. And you can do that. I wasn't able to explain it off the top of my head, so I wanted to record a video to follow up on that. And you had the right idea. It's just when you find the inverse of a function, you switch x and y, and then you solve for y. So if my original function is y equals sine inverse of 3x, and I want to find the inverse of that function, then I would take x and y and switch them. So I'd say x is equal to sine inverse of 3y, and then I need to solve this equation for y. So sine of x is equal to 3y, and then y would be equal to 1/3 sine of x. So I think the problem that you were running into was that you were just switching the x and y and saying that the inverse of this would be sine of 3x. But the inverse of this is y equals 1/3 sine of x. Now, I was kind of curious why we don't teach it this way in the first place, but after talking to Mr. Janssens and thinking about it and working through, I can see why we don't teach it this way. So I'm going to go ahead and go through this example, but I don't recommend that you do it this way. So if you just use the formulas that we learned in this unit, the derivative would be 3 over the square root of 1 minus 3x squared. Now, we're going to be able to get an equivalent answer using the derivative of inverse formula. So what we're going to do is we're going to say that this function over here, so this y is going to become my g. So g of x is sine inverse of 3x. And we're going to say that g and f are inverses, which would mean that I already found the inverse of this function. So the inverse is 1/3 sine of x. So if I want to know the derivative of g, and I use this formula, so g prime of x would be 1 over f prime of g of x. So g prime of x would be 1 over f prime, and then g of x is this, so sine inverse of 3x. And then if I go over here and I say, okay, the original function is 1/3 sine of x, the derivative of that function would be 1/3 cosine of x. So back over here, the rule for f prime is 1/3 cosine. Instead of x, it's going to be 1/3 cosine of sine inverse of 3x. So g prime of x should be 1 over 1/3 cosine of sine inverse of 3x. Now this 1/3 on the bottom can be flipped up to the top. You can multiply top and bottom by 3. So my derivative is 3 over cosine of sine inverse of 3x. Now this and this are equivalent. If you graph both of these, they're going to be equivalent graphs. But this would likely be on the multiple choice non-calculator portion. And chances are that the multiple choice answers would look like this, not like this. Now again, these are equivalent, and the way that we would show that is we would make a little triangle. So sine inverse of 3x is saying that there's some angle here. Like sine inverse gives you an angle. Not 3x is not the angle, 3x is a value, so sine inverse is going to be the angle that gives you that value. So if I just say z is sine inverse of 3x, then I can say that sine of z is 3x. And if I make my triangle from here with the angle being z, opposite being 3x, hypotenuse being 1, that would make the adjacent side 1 minus 3x squared. So if I do cosine of sine inverse of 3x, sine inverse of 3x is the same as 3 over cosine of z, and my z is this angle in here. Cosine would be adjacent over hypotenuse. So I'd have 3 over the square root of 1 minus 3x squared over 1, which again is equivalent. So you can do inverse trig using the formula for derivatives of inverse functions. I don't recommend it because it likely will not look like the answer that's on the multiple choice. But if you're on the free response portion, you could definitely do it that way as long as you find the inverse correctly. So hope this helps. Let me know. Talk to you later.